So, hello smart people again and welcome to my channel. So today we're going to continue from where we stopped on our previous video. Now we looked at how electrons are interacting within an atom, but now we're going to jump into the interactions between atoms. So it's quite interesting now because in between atoms we're going to be focusing on bonding. And bonding is really an interesting concept because this has really evolved over the past couple of years. First and foremost, we're going to be focusing more on the most fundamental concept that was introduced by Louis G.N. And it was quite impressive that Louis actually introduced a theory where he focused more on atoms bonding to form molecules, and this involves a filled shell of electrons enough for this particular atom or molecules to become stable. Interesting enough, he also further talked about the transfer or the sharing of electrons which has to be done in order for molecules to be formed, and as a result of that they will lead to the formation of a filled shell. So a filled shell must be generated as a result of the sharing or transfer of electrons, Mr. S. Now, this has to be done by, in order for we to form a stable octet rule. And this octet rule is mostly related to getting closer to the formation of your noble gas neighbor. Like say for example, if you want to form an 8-valence shell electron rule, that means that you need to go further in terms of forming a compound which is similar to that of the electronic structure of neon, and that is mostly related to period 2 element. On the other side, if you're forming an expanded octet rule, now this one is quite different because you're heading towards period 3 or greater. And now what happens then is that since you're introducing the d orbitals, d orbital tends to expand the number of electrons that is required for your molecule or compound to become much more stable, relating to your nearest noble gas neighbor, like for example argon or krypton or all those guys like that. So it's pretty much impressive how this kind of plays out overall. And now we're going to include the concept of sharing and transfer. Now, talking about the transfer is mostly leads to the formation of ionic bonding. Quite impressive while we talk about ionic bonding. If you recall, ionic involves either the formation of a cation or the formation of an anion, which is either a positively charged or a negatively charged. Now, the positive charged atom comes from mostly metals, and while the negatively charged mostly comes from the non-metals. So in this case, if I'm having lithium will have one electron in this outer shell, and in order for it to become stable, it needs to go back to the periodic table neighbor, which is helium. If it reacts with fluorine, which has 7 electrons in the outer shell, if it gains 1 more electron, it becomes neon. Now, what happens then is that this electron, you see the arrow, is just one-edged arrow, not double-edged arrow. One-edged arrow means I'm transferring 1 electrons, but if I'm doing this, it means that 2 electrons are actually moving from this to that, to and fro, toe and head. Impressive to think about that, because that will be crucial in further videos in terms of organic chemistry mechanisms. So if you're moving to this particular area, you're going to form a positive charged lithium and then a negatively charged fluoride, negative charge, and that forms lithium fluoride overall. So pretty much impressive because these 2 atoms, they fuse together by a form of an interaction forming an ionic bond overall. On the other side, if you're looking at another point of view, which is in terms of sharing of electrons, this will mostly lead to the formation of covalent bonding. And covalent bonding is really crucial in organic chemistry, in mostly molecules like carbon and stuff like that. We'll focus more on that in details as we move into future videos. Now, let's take for an example. We have hydrogen, one electron reacts with another hydrogen, another electron. In terms of sharing, we do one-edged arrow meeting at a point to form its closest neighbor, which is helium, H2, or if you want to say it in terms of the electronic state of Lewis structure, that is it for hydrogen gas. So thanks again for watching my video on covalent bonding, ionic bonding, and hope to see you guys on my next video. Please don't forget to hit the like button, share and subscribe. Have a good day, guys. Peace. Love you all. Bye and remain smart.